Hi. I'll just go through a few things about trigonometry and a few of the basic rules. The area of a triangle we'll go through first. And I think this proof would be something that we could see again in one of the coming up tests or one of these proofs. So I'll go through the proofs and then a few examples. Okay, area of a triangle. Now, the formula that most of you would be very, very familiar with is half the base times the height. And that's something that we've seen loads and loads of times before. Half the base times the height gives us the area of a triangle. So in this case, we don't have the height. We've only got the base, and we've got what A is, and we know what this angle is. So how can we change this formula into the one that we're aiming for, which is a half AB sine C? Well, what we might do is what we're going to do is just look at this triangle here. Now, we don't know too much, but what we want to do is find out what this H is, because that's in this formula, but it's not in the half AB sine C. So in this triangle here, one of the things we know is that sine of C, sine of this angle here, is opposite over hypotenuse. So sine of C equals H over A. And with a little bit of manipulation here, we can take the A up. So A sine C equals H. And then what we're going to do is we're going to substitute this straight into this formula. So instead of area being half the base times the height, we suddenly get that the area equals a half the base, which is B in this case, times the height. What's the height? A sine C. And now it is very, very similar to that, or it's exactly the same. Half AB sine C. I want to say that that's the distributive law, but I might be wrong there. I don't know the name. It's really fantastic. But B times A equals A times B. That's one of those rules that we started off with. But yeah. So how does this work? Let's look at a nice, simple example. Or maybe you can just stop the video here and see if you can figure out that. That's a nice, simple one. We're in degrees. This could be radians, remember. Could be, what would this be in radians? Well, we know that 180 equals pi. So 60 is going to be pi on 3. Would be exactly the same question if it was in radians. So what would this be in terms of the area? The area is just going to be a half AB sine C. Very, very simple. A half times 12 times 10 times sine 60. And that would just be a matter of plugging that into the calculator. It wouldn't be very difficult at all. And if we got a question like that, I think we should all be cheering. And that's just 51.9 centimetres or units squared or whatever that is. More likely we might get a question like this, and certainly this is more out of the tutorials. The area of this triangle is 80 centimetres. Find the value of x. And again, might be an idea just to stop and have a go at it before I do it, and that way you can work through it and see how close you got. But substitute, this is obviously different because the formula is area equals a half AB sine C. Well, we've got the area in this case, a half times x times 10 times sine 30. Again, what would sine 30 be? 30 degrees, or 180 equals pi, so 30 equals pi on 6. We could have used pi on 6. So this is just a very similar thing. We're just taking everything over the other side. We're times in by a half, so we can divide by a half on the other side, or times by 2 is going to give you 160 equals 10 times x times sine 30. Divide by 10 gives us 16 x times sine 30. Now we know that sine 30 is a half. We can do that on our calculator. So x equals, or x times a half equals 16, so x would equal 32. And that's basically it. But If you go back to the proof, as I said, it was a very quick proof. I think Alan, or in this course, it would be very, very surprising if we weren't asked to prove one of these three things, because I think they fall out fairly quickly. Hopefully that, and I'll do the proofs of the sine rule and the cos rule too. Thanks. Bye.